Yeah, hello guys. How you all doing? My name is David Olutunde Daniel, and today I want to talk about a specific topic in abstract algebra. Titled. Just a minute. Let me see. The topic is titled. The fundamental theorem of finitely generated abelian groups. So what does this state? So it states that it says that if you have, let's say for instance, a group G, if G is a finitely generated abelian group, then it says then there exists r greater than equal to 0. So the rank, this is the rank, yes. And you also have the primes, say p1 less than equal to p2 dot dot dot, less than equals to pk, and m1 m2 dot 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 mk, such that G is R times Z of P1 M1 and times dot 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 times Z of PMK Z of K. So where the PMII are called the elementary divisors. So this is from the definition of source, Nathan Williams. He's an assistant professor at the University of Texas at Dallas. He's such a great professor. So let me just start. What is this all telling you about? He said a group, let's say G, is a finitely generated abelian group, and there exists R. R is the rank, such that is a non-negative entity. And you also have your P to be primes and M, and M also, such that you have this. So basically what I want to do is, let's say for instance you are given a problem. So this is let's say problem 1. Let me call it problem 1. You are given that you are asked to determine, let's say, the structure let me call these A. So determine the structure in the form of A, or in the form of statement, in the form of A, of the finitely generated abelian group. Yes. General abelian group. So generated by three elements x, y, z, subject to the relations 2x plus 4y. Should I use a pen? Okay, 2x plus 4y plus 2z equals to 0. 12x plus 6y plus 4z equals to 0. 8x plus 3y plus 3z equals to 0. So, in order to solve this problem, so we are going to use a method called the Smith normal form. A Smith normal form. So I might not be able to give you the full definition now, but you will, because it's not necessarily important. The major thing is you getting the step and you'll be fine. So let me put this in a matrix form. 2, 4, 2, 12, 6, 4, 8, 3, 3. So to solve this problem, you might say, oh, I want to use the conventional row reduction, column reduction, but it will be shocking to let you know that it might not work. Yes, it might not work. So what I would advise you to do is just to follow, just to follow this up, because it might really be of importance. So this is my matrix: 2, 4, 2, 12, 6, 4, 8, 3, 3. Now, if you try to solve this problem, let's say for instance, it looks like you can start with 2. However, you don't really know what you might start with, because now you have 3. 3 is not, you can divide, is not, they will give you a remainder. So you can say, let's say for instance, you can change the column or you change the row. Let's say for instance, okay, let me exchange row 2 with row 1. So the reason why I'm doing this is because if you look at the diagonal, this right diagonal, 12 and 3, 12, you can easily, you can divide 12 by 3, of course. And you can divide 4 by 4, 2 by 6. So you don't really know which one you should use as the critical, critical or pivotal element, you understand? So what I need to do is I can exchange this row. So if I exchange this row, I have 2, 4, 2, and I have 8, 3, 3, I have 12, 6, and 4. So now, if you look at this diagonal now, you discover that 2 and 3, if you divide this, it's like you're saying 3 equals 1, 2 plus 1. So then you have 2 equals 1, 2 plus 0. So it means you need this one. Yes, it means you need to find a way to reduce the largest of these to 1. That's what you need to do. So here, that means your 3, you need to find a way to reduce it to 1, because this is the remainder. You need to find a way to reduce it to the remainder. So in order to do this, I can say that R1 minus R2. So this gives me, this gives me 2. So don't forget, this is going to R2. So this gives me 2, 4, 2. This gives me, if you add 2 minus 8 minus 6, 4 minus, this is 1, and this is 2 minus 3 minus 1, this is 12, 6 and 4. So this, now you can change the column. Let's say I want to change the column. Let me transfer this column to column 1. So if I do that, I have 4, 1, 6, 2 minus 6, 12, 2 minus 1, 4, and yes, now I can exchange R1 with R2. Yes, so this gives me 1